Welcome to ClickMyProject.com. Our project entails VLSI architecture for delay efficient 8-bit multiplier. Our project abstracts this is based on that approximate radix booth multiplier. Based on 4 booth multiplier consists the booth encoding process. Modify the booth encoding based on the MBE to reduce the number of partial product generation. This is a booth multiplier for the proposed method, existing method for the VLSI multiplier. So booth multiplier consider the 3 part. One is a partial product generation using the booth encoder. Another one is a partial product accumulation using the compressor, and then finally product generation using the fast adder. So 3 process based on the booth multiplier concept part. The booth encoding has a proposed for the improving the performance of multiplication of 2 complement binary number. It has the future improved the MBE modified booth encoding or the radix 4 booth encoding. So they finally calculate the error of approximate adder and multiplier, including the mean error distance and the relative error distance, and the normalize of the booth multiplier. The VLSI also the 4 VLSI encoding process. Our process flow diagram is first of all the input data bit. The input data bit is a 2 power 0, so this is a 1 bit. So after that, using the 3 generation for the radix 4 booth multiplier concept. One is a partial product generation, so another one is a partial product accumulator, and finally product generation. So this is a 3 methods compress of the radix 4 booth multiplier. The existing method for the VLSI multiplier, the proposed method for the radix 4 booth multiplier. So after this is a deregistration architecture based, the approximate partial product array will be generated. That array wise we are calculating the error complexity. So the error correction operation block, finally calculate the simulator and synthesis analysis. So simulation and synthesis analysis based on the behavioral model check, and then simulation model will be checked. Architecture delay the 8-bit multiplier. So they using that the VLSI code. So using that the Xilinx ISC 14.7, we are using the implementation of VLSI code. So this is a multiplier concept. So this is a 2 model. One is a behavioral model, another is a simulation model. So behavioral check the semantics have successfully. After the simulated behavioral model, so weighting the complexity of the CPU basis. So this is a CPU based on the 936 seconds. So this is the input data. So after that, this is a RTL basis. So first set the constant force value 001. This is D1 generation. After this values, and then clock set based on the 0 based on off, and 1 based on the on. So clock set on. So and then reset based on the 0. So this is the input. A and B has the input. This is a clock set. This is the finally output. So this is a proposed of a 8-bit multiplier.